In this episode, we're going to tackle a category of problems that can feel surprisingly personal, even though it's purely technical: Git authentication issues. When authentication fails, it often shows up as a blunt message that you don't have access, your credentials are rejected, or you are not allowed to push, and beginners sometimes interpret that as, "I broke something," or "the system hates me." In reality, authentication is just the gate that protects the repository, and those gates are designed to be strict because a repository is a high-value asset. Your goal is not only to get yourself unblocked, but to fix the issue in a way that doesn't weaken security or disrupt how the rest of the team works. That means avoiding quick hacks like sharing passwords, disabling checks, or moving code outside approved systems. A calm, secure fix starts with understanding what Git is asking for, what identity it is trying to use, and what kind of authentication your team expects you to use. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyber.author.me in the Bare Metal Study Guide series. The first concept to nail down is the difference between authentication and authorization, because people mix them up constantly. Authentication is proving who you are, like showing an ID badge at the door. Authorization is what you are allowed to do once you are inside, like whether your badge opens the server room or only the lobby. Git authentication issues are about the first part, meaning the system does not accept the identity you are presenting, or you are not presenting any identity at all. Sometimes the error message mentions access denied or permission denied, and that can be confusing because those words can refer to either authentication or authorization. A systematic approach begins by asking whether the repository host recognizes you as a valid user and whether your Git client is actually sending the correct credentials. Once you can authenticate consistently, authorization becomes the next layer to verify. But the safe order is to solve identity first before you assume the repository is blocking your rights. Next, understand that Git can authenticate in different ways depending on how you connect to the remote repository. Two common connection styles are a web-style connection and a secure shell connection, and they use different credential flows. One style typically relies on tokens or password-like secrets, while the other relies on cryptographic keys. Teams choose one or the other, or sometimes both, based on security policy, platform support, and ease of management. Authentication issues often happen when your local Git setup is trying to use one method but the remote expects the other, or when your credentials are valid for one host, but not for the specific repository you're trying to access. Another common issue is that a credential used to work but was rotated, expired, or revoked, and your machine is still trying to use the old one. The operational goal is to align your local connection method with the team's approved method and ensure your local credential storage is not feeding Git stale secrets. A secure troubleshooting path starts by identifying exactly which remote you are talking to and what protocol it uses. Beginners often assume there is only one remote and only one account, but real projects can have multiple remotes or different URLs that look similar. If you are pushing to a company-hosted repository versus a personal repository, your identity and permissions can differ even if the project name looks the same. If the remote URL points to a different host than you expect, you might be trying to authenticate to the wrong place, which leads to puzzling failures. There are also cases where an organization requires single sign-on, device compliance, or additional checks, and your authentication will fail until those requirements are satisfied. The safe approach is to confirm the remote target and the expected login identity before changing anything. This prevents you from making risky changes to credentials when the real issue is simply that you are pointing at the wrong destination. Once you know the target, the next question is which identity Git is actually attempting to use on your machine. Authentication failures are often caused by the wrong cache credentials being presented automatically, especially on systems that store credentials for convenience. This can happen when you have multiple accounts on the same host, such as a personal account and a work account, or when you recently changed your password or token. If Git is silently trying an old credential first, it may fail repeatedly even if you think you've updated everything. A systematic fix is to clear or update the specific cached credential entry for that host, and then ensure the correct credential is stored going forward. The security goal is not to disable credential storage entirely, because that can lead to unsafe workarounds, but to make sure what is stored is correct and minimal. Teams rely on predictable authentication, and predictable authentication depends on making the local machine's credential behavior transparent and intentional. Another frequent cause is token policy, because many teams have moved away from password-based access in favor of short-lived tokens or scoped credentials. A token is not just a password replacement. It often has specific scopes that limit what it can do, and it may expire on a schedule. If your token does not include the ability to push, you might be able to read but not write. If it is expired, it might be rejected immediately even though it looks valid. If it was created for a different account or organization, the host will not accept it for your repository. The secure fix is to obtain a new token through the team's approved process, ensure it has the minimum required scopes, and store it in the approved credential manager. What you should not do is ask someone else for their token or share a token across machines, because that breaks accountability and creates risk. In secure workflows, each person's access should be traceable to them, and tokens are part of that traceability. If your team uses key-based authentication, the most common beginner issues are using the wrong key, having the key not loaded, or having the key not registered with the repository host. Key-based access depends on your local machine having a private key and the remote host having the matching public key tied to your account. Problems arise when you generate a new key but forget to add it to your account, or when you have multiple keys and the wrong one is being offered. Another problem is that the key is encrypted and requires a passphrase, but the key agent that supplies it is not running, so Git cannot use it. The secure approach is to confirm which key your client is attempting to use, ensure that key is the intended one, and ensure the remote host has the correct public key associated with your identity. Keys are powerful because they can provide strong authentication without reusable secrets, but that power also means you should manage them carefully and avoid copying private keys around casually. Good team workflows treat keys as part of device trust, not as something you email to yourself to get unblocked. Authentication issues can also be caused by organization-level policies that sit above Git itself, and beginners often miss this because the error feels like a simple login problem. Many organizations require multi-factor authentication for web logins and also require that Git operations follow approved methods tied to that same identity. Some organizations also enforce single sign-on and will reject access until your account is linked properly or until you have completed an organization login flow recently. Device posture checks can also matter, meaning the organization may require that your device meets certain security conditions before access is granted. When these policies are in play, the fix is not to change Git settings randomly. The fix is to satisfy the policy requirements, which might mean completing a login through the organization portal, enrolling your device, or updating an expired session. The operational goal is to fix the root cause without bypassing the controls that are there to protect the repository. Secure workflows are built on these controls, so bypassing them creates problems later even if it gets you past today's error. Another subtle source of authentication failure is mismatched identity when using automation or multiple environments. If you use Git on a work machine and a personal machine, or in a development environment that runs in a container, you may have different credential storage and different account contexts. A token stored on one system does not automatically exist on another, and a key that works on your laptop might not exist in your remote environment. Beginners sometimes respond by lowering security controls to make it work everywhere, but a better approach is to keep strong authentication and manage each environment's credentials properly. In team workflows, it is normal to register separate keys for separate devices or to use scoped tokens that are specific to an environment. This reduces blast radius if a device is lost or if an environment is compromised. The secure habit is to think in terms of identity per device and minimum necessary access, which aligns with how professional teams protect source code and infrastructure definitions. When you're fixing authentication, it's also important to avoid disrupting others, which means you should not change shared remote settings or repository permissions as your first troubleshooting step. Beginners sometimes try to fix their push failure by changing branch protections or turning off required checks, but that alters team governance and can weaken safety. The safer path is always to fix your local identity and access first. Then confirm that your account has the correct role or permissions if needed. If authorization is the issue, the correct workflow is usually to request access through the team's process rather than to make ad hoc permission changes. This preserves least privilege and keeps audit trails intact. A secure team workflow is not just about protecting against attackers. It is also about protecting against accidental changes that bypass review and break project discipline. Your personal convenience should never be the reason a team's controls get weakened. To bring it all together, think of Git Authentication troubleshooting as a disciplined identity alignment exercise. You confirm the remote destination, confirm the protocol and expected authentication method, and confirm which identity your local Git client is actually presenting. You clear or update stale cache credentials rather than layering new secrets on top of old ones. You use approved tokens or keys tied to your individual account, with minimal scope and proper storage, rather than borrowing someone else's access. You account for organization policies like single sign-on and device requirements, because they can block you even when your credentials are technically correct. When you solve authentication this way, you get unblocked without creating new security risk or confusing your teammates with sudden permission changes and workflow disruptions. That is the real outcome you want. Your Git access works reliably, your team's security posture stays intact, and the repository remains a trusted source of truth for everyone.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit BareMetalCyber.com.